Hello everyone, this is Vikas. Recently we implemented Raft consensus algorithm in Typescript. So this is the Raft consensus. So what happens in Raft is like every node has a state of either it can be a follower or a candidate or a leader. So whenever the system starts, it contains a certain timer. So let's consider S1, S2, S3, S4, S5 are the nodes, and let's initially every node will be a state in the state of follower. So I did consisting of a random time mode between 1.5 seconds to 3 seconds. So when we on the all systems, every system any system which has less time mode will expire first, and it becomes from follower state to candidate state. So right now S1 time expired and it becomes to follower to candidate, and it's asked for votes to every other node in the network. First part of the graph consensus algorithm is electing a leader. So every other node in the network starts, it starts with a random timer. So whoever in the network has the least time mode, it expires first, and it transitions from follower state to candidate state, and it requests votes to every other node in the network. So S1 it have a less time, and it expires first, and so now it starts sending request vote signals to every other node in the network. Then every node accepts that we have the voting mechanism majority by minority. So every other node in the network has given a vote to S1, and S1 transition from candidate state to follower state, and S2, S3, S4, S5 are in the follower state, and S1 is the leader of the network. So at a certain interval S1 so it need to send heartbeat signals to every other node. So S2, S3, S4 and S5 have a random time mode. So whenever the time mode expires, the election voting process begins again. So in order to avoid that, S1 will send a heartbeat signals to every other node. So every time they receive a heartbeat signal, the timeout of the node will be increased. So let's see, S5 receives and it has increased some timeout. So if I want to send some information to from outside this network to from outside the network to this distributed system, I need to send it to leader. So let's send some request to leader. Since S1 is a leader, we can see that in the logs of S1 there is a state called, in the one position there is a 2. So after we start this, S1 will send to update a request to update. As we have seen, we have sent some request to a leader node that we change the logs of leader node. Now a leader node logs will be replicated with other follower nodes. So it sends a signal that we need to change some replicate logs in the other system. So when they receive the request, every other node will replicate the logs of S1. That's a leader node. So what if sometime leader node dies or it stops working? So let's stop the node and rerun the network. Right now, after certain interval, there is no heartbeat. Since there is no heartbeat, nodes will be expire first. I think S2 will expire first, and it becomes a candidate, and then it start requesting votes to every other node in the network. Let's see. S2 will expire first and request votes to every other node, and S2 becomes the leader of the network. So what if we rejoin S1 into the network? Let's first send some request to S2 and see whether it can replicate all logs in the other node or not. Yes, we can see, but since we have turn off the S1 node, we can't see the logs. So if we turn on this node, restart this node, S1 should receive the exact logs of leader node in that system. So let's see. Yep. Yes, as we can see, the S1 logs are replicated with the leader node, that's S2. So this is how the Raft consensus works. This is algorithm in action. I have opened like five nodes, I have a single Raft node instance. So I'm creating 5 different instances of single Raft node in the different ports like 3001 to 3005. So let's run every node in the network. So let's save to restart the network. Okay, so here, as we can see, the timeout for the 3000 node is 7000, and timeout for this 3001 is 7400, and 9000, 9100, and 5000. So what happened here was, like, since the 5000, the 5 millisecond time, 5 seconds time was less, so 3005, 1, 2, 3, and 4, fifth 3005 port has become a leader, and it starts sending heartbeat signal to every other node in the network. So as you can see, received heartbeat from the ID 3005. So what if we kill the leader node, and eventually what should happen is, like, out of 4 nodes, any one node should be the leader. Let's kill the leader node. So I have stopped the leader node. As you can see, let's see what happens. Yep. So since from 1 to 3001, 3002, 3003, and 4, 3001 has a least timeout, so it sends a request code to every other node in the network. So as you can see, term 1 report granted. So 3001 start become the leader, and it send heartbeat signals from 3001 to every other node. As you can see, received heartbeat to 3001. So since 3001 is a leader to the network, let's send some commands to 3001 from outside the network. So I'm using Postman to do that. So 3001 is a leader. Let's send some. I have an array of 4 numbers. I'm setting the array of 0th index to some 100. Let's send the request. Okay. As you can see here, we have saved the logs of here, and before the state change there is a 00, and after the state change there is 100 at the 0th index. So it's replicated to every other node in the network. So here we have a leader to the network. So what happens if some new node want to rejoin the network? So let's rejoin node 5. So after node join restart in a network, it becomes a follower to the leader. Since 3001 is a leader, it starts receiving heartbeat signals from 3001. So let's check the log of 3001. Let's set 1th position to 150. Anything. Okay, let's see the logs of every node. As you can see, the log entries for all the nodes are equal. Here, and the state change before and after will be updated in every other node. So this is the Raft consensus algorithm implementation in